Guys, welcome to another video of mine. Okay, so this is a new project that I've been working on. It's a compiler for it's a compiler for a C-like language. Okay, right. So here I have my a debian file here. So wait, let me just clear all of this. Here I have all my files. Yeah, I'm just gonna remove that one file, gdb.txt. gdb.txt. I'm sorry about that. ls. There you go. This is my program, and this is what it looks like. Yes, and this is my program folder. Correction. Sorry. This over here is the program itself. This is an example. This is the input that this program takes in. Code.cmm is the input for CMM, and you do it like this. It's like //cmm. This thing, code.cmm. So you can see here it does this. I'll explain what that means in a minute. But as you can see here, then you also have the main.c, and then here you also have the make file. Okay. So now let's just check what's actually in the main.c for a second. So now this is what my program looks like at the moment. At this moment, it's just a Lexer, or yes. So here we have a function here that just reaches the next symbol. So basically, the way it works is that whenever like we're parsing the string, we read at one symbol at a time, not just like turn the program into a list of tokens. We just turn the we just do it as we get reading the input, right? So now so as you can see here, this is the next symbol function, and in case that this reminds you of another program, it's because I'm basing it off of this one. I started off a video on YouTube. Off of this file. As you can see here, this is a stripped down version of C, right? And so as you can see down here, as you can see up here, this is I'm basically making recreating this function. It's basically this function is basically that function, but instead I actually return a token. And as you can see here, and yeah, we can see, for example, we can see all the cases for all the single symbol inputs, right? So we have the back bracket and the forward bracket, no, curly bracket, and then we have the back parentheses, forward parentheses, and then the plus, minus, less than, semicolon, and equal sign, right? Now mine is a bit different because as you can see here, my tokens are defined in a different way. Okay. So firstly, a number can be from any number from 0 to 9. I'm using regex here. An identifier can be is something any word starting with lowercase a to z. Actually, I'm just gonna remove this part because honestly I'm not care about that at the moment. No, I'm actually gonna remove this part too. Okay. So it's basically just it starts with actually, you know what, at this point I might as well. Yes, okay, I'm sorry about that. Okay. So an identifier is just like a string of at least one semicolon or a lowercase letter. Then we have the all the words that are just lowercase are just like terminals in the language. So we have the if, while, do, else, and then here we're back to a specific character. So LP means left parentheses, RP right parentheses, LCB left curved bracket, RCB right curved bracket, EQ equals, plus, yeah, I think that's obvious, minus or minus sign, LT less than, GT greater than, IE is equal, not the same as equal to, is equal, not equal, and then you have and, which is, yeah, no, I'm just gonna yeah, no, I was originally planning to make the and or operators a double, but I decided to just go for like single, since we're not really going to do do binary operators here, but maybe sometime in the future, but not right now. We're not gonna focus on that right now. Then we have the not thing, and then you have semi, and then finally the last one that I forgot to put in before, let. Now now we have the this thing, the enum token type, where it just enumerates a bunch of tokens, or yeah, an enum of tokens. So here we have if, while, do, else, let, and so on and so forth, the same ones we saw here, plus EOT, which just stands for which just means or EOT, all it does is it just marks the end of the file, right? And then I'll explain what this one is for. But as you can tell, it just holds the actual letter characters for yeah, for each one of these for each one of these, right? If, while, do, else, let, for all the for all the terminals that are actually strings. Then I have here defined a token. It's just an type integer, an integer type, and no. This one represents what kind of token it is. So it could be like an if or while token. This one represents this one like tells you if it's if it does have a value, like for example, if it's like an identifier, then it's going to be it can either be a string or a value at this part, right? Now we have a character, right? So now this is the current character I'm going to read. I'm going to find a function here called nextchar to put the next character into current char, or the current character. And as you can see here, this is basically just this part from the part. I'm also yeah, this part also comes from this part, right? So okay, so as you can see here, in the next symbol thing here, we have the sorry, in the next symbol function here, it basically it initializes the current token, and here's a forever loop. So basically, we have a switch statement here that's based off the current character. And if it's like white space or an enter symbol, it just goes to the next character. It ignores it completely. And if it in case that it's the end of a file, yeah. And basically for all these single character operators, or all these single character terminals, it simply does a simple check on that to see to define the type of it, and just set the value to 0 since we don't really need a type. And then we automatically read the next token, the next character. For when you call it again. However, if it's not any of these, the left parentheses, the right parentheses, the left curved bracket, the right curved bracket, the plus symbol, the minus symbol, the less than symbol. Wait. Oh shoot! I forgot to add the greater than symbol. So wait. Hi. Shoot. Okay, so now, let's see here. Actually, I should probably check. Do a just check if I have all of them here. Yeah, I think that's all of them. Hopefully. Okay, so now this handles like two character operators no, this handles two character terminals, right? So as you can see here, and over here. The not terminal and the not equal terminal both start with an exclamation mark, right? So in that case we have to check if we have to read the next character and see if it's an equal sign, and if it is a not equal sign. Otherwise it's just a not symbol, not sign. And if it is a equal and if it is a not equal sign, then we also read the next character. But otherwise, we just leave it as is because we already read the next character, and we're just gonna let the next function call decide what that is actually. And so we can also see here that that the is equal sign and the equal sign are the same for obvious reasons. So we also check for that here too. Yes, if the current character if there's an equal sign, then we check again if it's there's another equal sign following it. And if that's the case, we just set if there are two consecutive equal signs, then we just set the current token to is equal, and we read the next character. Or if there isn't any, then it's just an equal sign. Then yeah. Now this one handles numbers. If the current character is between 0 and 9, or in other words, it's a digit from 0 to 9. We set the type to be a number, and we actually set the current token value to be like 0. We initialize it with 0, and then we use this formula over here to continually keep expanding it. No, to continually keep turn the string into an actual integer. We can we can do this because of the in ASCII each character can be represented as a number. No, each character is represented by a number from 0 to 127, I believe. And so here all these digits from 0 to 9 are within 0 to 9. So using some fancy math, we can keep reading until it's still a character. So now once we've done that, we just return a character. Here this checks for ID. This does a similar operation, but instead we just build a string, and we also add the terminal string here. Now this part is actually quite interesting. So I basically just copy and pasted this, or no, I just took a really similar approach. Well, basically same approach. I basically just so here I just reuse the same actually I should probably add more white space to make it clear what's happening here. Give me a minute and just add some more white space. Alright, I'm back. I just added the program a bit. I just added I just added a bit of spaces here and there just to make it a bit clear what's happening. So here this is so here what it does is that it uses the same variable, the same I variable from the same index variable from here, and just sets it to 0. And so basically what I did here is that well, I basically just we did what they did in the original program, where sorry about that. So as you can see here, the each of the longer than one character terminals are in the exact same positions as they are in the enum here, and that's no coincidence, because so as you can see here, do is the first one, else is the second one, if it's the third one, and while is the fourth one. And so the reason why they do that is because so that they can so here the symbol is just represented by number. So when the symbol is 0, it's equal to the if, it's equal to do actually. And so what they do here is that the word is that they compare the first letter, or the letter that corresponds to whatever the value of the do symbol would be, so which is do, or the string do. In other words, basically all it does is just confirm, check if it's check if each one is sorry, wait. It should just confirm is if I is equal to, oh no, if the so basically just checks if it's not like the end of the words list, and checks if the current word if the current word is the same as the string that were read, and if it is, we just give over here, and if the word that we ended up on is the 0, then we just set as the ID, because that means that it didn't match any of the previous ones. Otherwise, we just set the token type to I, because if it did stop at some point, then I would represent would be the corresponding longer than one character terminal. So stopped at say number 2. If I stopped at 2, then it'll go 0, 1, or if the string was due, then if I saw 0, then it'll compare if to 0. It'll compare the first one to 0. No, it will if the string was due, then I would first be set to equal to 0, and then I would be at first it'll compare do with if, which is obviously not the same. Do with while, which is obviously not the same. At this point, I is equal to 1, which corresponds to that one, and then finally it will do I equals 2 or compare do to do, which is obviously do. And since I is equal to 2, that it's set to the number 2, which is the value of the enum for do. So yeah, that's basically just the function for creating tokens. And so here, this is just for later when I actually create the parser. But that doesn't really matter for now. But basically, what I'm gonna do here is I'm gonna create so basically all this does right now is just read from the file that I showed you from before, and it's going to take the and it's going to just print out the number the sum the number of each symbol on the number of each symbol that it reads. Okay, so let's just actually test it out for right now. So just run make. Let's just go and then finally just do the code. So as you can see here, we have a list of values now. Now let me just open another terminal window. So now at this point, what we can do is we can type helix main.c, and then just check the enum to see which one corresponds to which one. Okay, does it fit on the terminal screen? Yeah, okay, I think it does. Yeah, just barely, but yeah. So let me just there you go. So now this is 0, this is 1, this is 2, and so on. Okay, so let me just run the command again, and let's just all see see it in another in another one, the example program. So let me just open the file. Okay, program. Okay, sorry. C and then C minus code.cmm. Open. So I'm just gonna just leave it as a little file here, or no, as a little window here. So now, as you can see here, the first symbol would be if, and correspondingly, the first symbol it reads is 0. Then it's left parentheses, ignoring the white space, of course. So it gives out a value of 7. Now let's check what 7 is here. So 0, 1, 2, 3, 4, 5, 6, 7 left parentheses. Indeed, it's the right one. And then it reads a number, so it reads a number. So it reads a number, so it goes to 5. It's as you can see here, 5 is 1, 0, 1, 2, 3, 4, 5. It's it correctly identified it. Then the next one is an ampersand, which means the AND operator. So we get the value 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16. Wait, 0, 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, I'm sorry about that. Wait. Let's consider it one more time. 1, 2. Oh my god. 0, 1, 2. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, am I tripping? Am I tripping? Shoot. Sorry about that. Oh my god. Of course there's more. Okay. Let me just start over from the beginning. Oh god. Okay. 1, 2, 3, 4. No, 3. This will be 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, it was right. I just had it wrong here. So let me just. I'm sorry. Let me just open the source file again. So now we see that so now it's again a number, so it's 5 again, which we already know is a number. Then we have 8 here, which is the left curly bracket. It should be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Wait. Oh yeah, no, it should read this one first, the left parentheses. Then after that should read it should read 9, the right curved bracket. So let me just show it here on screen. We know that this one is 5. So this one is wait, no, this one is 8. Okay, sorry about that. You know what? Sorry about that. So let me just check. So I'm sorry. Well, I think you get the point. I'm sorry about that, Jenna. Sorry, but I think we get the point. Basically, the Lexer actually like to recognize these tokens and can read it from it. So obviously, the next step would be to create a parser to actually parse the string and create an AST for the program. So here so like, as we can already see like how it's starting out. So yeah. So yeah, it's a pretty neat project I'm working on. I might even record myself. Well, no, I don't think I'm gonna record myself writing parts because I really want to write it right now. But yeah, yeah, you may see a video soon of me writing parser. So yeah, it's a pretty neat program. I'm gonna keep working on it, and so yeah, um, yeah, I think that's it. That's it for right now. So bye.